All right. Well, good afternoon to, I guess, morning, and I'm not sure there'd be evening for any of our attendees, but if there is an evening, good evening. Once again, welcome to today's webinar entitled 10 Racking Mistakes Warehouse Managers Must Avoid. I am Marc Rousseau. I head up national accounts for Damotech, having been with the company now just over 6 years. My partner in crime is our chief engineer, Charles Carbonneau. He will doing the bulk, I would say, of the meaty portion of the presentation, and I'll be off camera very shortly, so you won't have to stare at my ugly mug too much longer. Charles, forgive me again, how many years have you been with us?
Since 2012.
2012, so 9 years, very close to that magical 10-year landmark where we all get to celebrate, have fun, party, all the like. In any event, so again, we'll be sharing today's presentation material. So without further ado, let's go and get into the crux of the presentation. Right, so Damotech, for those of us, or those of you that don't know us, we were established in 1989. We're North America's leading warehouse rack safety partner. The picture you see before you is our main facility. We help companies address their rack safety concerns by providing engineering inspections, training, warehouse rack safety management software, rack protection, and repair solutions. Let's set the stage a little bit, if you don't mind, to kind of get folks acclimated with what we'll be covering today. Did you know that on average, a 100,000 square foot warehouse in the food and beverage industry, now we're using that as a model for this particular stat, that average warehouse will have high priority issues on or about 10 to 15% of its racking. Now, I have to caveat this, that this is usually in the initial stages of an inspection when someone hasn't really developed a full-blown rack safety program. So 10 to 15% of that racking will have had some degree of high priority issue associated with it. Now, of those issues, 3 to 5% of them will likely require an immediate unloading due to the risk of collapse. So if you take that into context, and most of you out there are able to kind of figure out the size of your facilities, but this is data that we've accumulated over time since we've been doing this now for going close to 10 years. These sort of issues are important, and it allows me to kind of transfer the presentation to stuff like this. Now these are videos that you may have seen on social media. And the idea behind these videos is not to scare anybody, but to say that you don't need to be riding full tilt into an upright in order to cause a collapse. Oftentimes, it's a small repeated damage that accumulates that renders that particular position more susceptible to a collapse. This has to do with housekeeping, people not necessarily pay attention to the narrow space that they have to navigate, and the driver clips the upright, of course, causes a collapse. And I always say, and what we always say, forklift versus upright, forklift will always win. And this is one that's a bit more popular, and I say that, tongue in cheek, mind you, because it's never fun to see these kind of things. But again, just a very minor collapse on a system that was not properly designed. And we could see that the design of these systems, because they're all kind of interconnected, causes a flurry of very traumatic damage to the uprights, not to mention potential injury or loss of life. So with that, I want to just say, hey, we're not making this stuff up. The images that you're going to see today, the pictures that you're going to see during today's presentation were all taken by our engineers that travel across North America performing inspections for various clients. Now, today's presentation is not a sales pitch. It's one it's intended to be educational and to make you aware of things that could be very helpful as you look to maybe shift the thinking around rack safety in your various organizations. So more of a note than anything else, there will be a quiz at the end that you'll be able to take. It's more of a self-assessment to ensure you understand where you sit on the spectrum of rack safety. Are you someone who is maybe more novice? Is your facility maybe more prone to needing help versus maybe someone who's an expert? Maybe you have instilled all the right things that need to be instilled as part of your rack safety program. So though towards the end of the presentation, you're going to see a link to be able to do that. So with that, I've talked enough. I will now hand it to my partner today, Charles Carbonneau, for this part of the presentation. It's all yours, Charles.
Thank you, Mark. So obviously, guys, when we do a top 10 like that, we cannot have the absolute truth. It's just something that we see in the warehouses that we visit. So we created that top 10 to try and put some order into what we think is really important and must not be missed. So at number 10, we have using inadequate or no protective devices at all. So as you may have noticed, damages from forklifts to rack systems happen oftentimes at the end of aisles or at the tunnels where they take their turns, right? So oftentimes if these locations are not protected, you may damage the racks. But there's also damage to building columns like this one. So I'm not saying this is inadequate, at least they tried something. So when you have these wooden piles surrounding the column, you know, the first hit, you may bounce if it's not too hard, but each time you're hitting the wood, it is kind of transferring all the force to the column. And it is kind of hiding what's happening to the column because it is basically covered by this thing. So there's some energy absorption. It's not bad, but there's better solution. And of course, if you don't have anything at all, well, you're exposing yourself to that kind of issue. And in the case of the concrete column, maybe they can pour, you know, a larger concrete base and re-protect it. That could be done. But in any case, you'll have to ask the engineers to get involved, because once you've cracked the concrete like that, the engineers will want to know what's happening to the rebar in there. If we recast what capacity that column has to have, and remember, they have to take full responsibility for their actions once the work is done. So it's going to cost, basically. And the same thing goes for the one at the bottom, the steel column that's been pierced through by the forks. It's not an easy repair. Every situation is different. In this case, we can see, I don't know if you see my cursor, on the left side here at the bottom of this red column, that the flanges were deformed as well. So you can't just go and try and weld stiffeners at the bottom there because this is deformed. You might have to reheat it up with torches, and all of that work needs to be supervised by an engineer. Another case where they protected with a wooden post, an upright, and you can see that it's been hit pretty bad. The whole thing has been destroyed. You know, the protector, the wood protector is destroyed, and so is the column base. Now, this is an interesting situation where you have a steel guard solution, but it might not be totally appropriate, because with multiple hits, it seems to whiplash towards the column now. So this thing, when we were visiting this, we could kick them and they would just move and hit the column. So basically, you no more protection, or not the same idea of protection that you wanted to have in the beginning. At number 9, not using your racks as intended. So the pictures will speak for themselves. Look at this. This is an upright extension, or, you know, just 2 posts that seem to be just taped to the extremity of existing uprights. They're not even the same shape of uprights, of posts, I mean. And in this particular case, usually a rack is not supposed to carry horizontal loads by these carpet rolls that we see right there. They are leaning against the column, and typically racks are not designed for that. So it's a double issue. You know, you're using rolls, you don't have anything to protect your uprights or to support the rolls, and you're using these extensions, which are nonsense, really. This middle picture here shows neatly placed steel elements, but they're sitting right on top of horizontal braces for that upright. These two uprights, I mean. And so originally a rack is not intended to support any kind of horizontal loads on the horizontal braces of the upright. Loads are supposed to be put on the beams, the horizontal elements that support pallets. Another case here, you see this line of tubing that goes along the aisle, the end of aisle of this rack system here. I'm not sure exactly what it is, but they have attached it to the horizontal braces of the upright. And you can see how badly deformed it is. And so this is really twisting the column. Therefore, it is also limiting or reducing the capacity for vertical loads that come down from the pallets that are stored up there. So you're really damaging your rack and impacting its load capacity. Moving along at number 8, connecting racks to the building structure. So you have to know that in the rack design codes, racks are designed to be standalone. They're supposed to support all loads, including seismic loads and operational loads, you know, impact loads from dropping a pallet, from side shifting. All of these are supposed to be part of the original design, which was never intended to be attached to the building. The problem is when you attach it to the building and you have some, I don't know, a horizontal force, like in this example here, you can see these yellow braces that are attached to the roofing system, right? So you imagine if you have a seismic excitation, seismic vibration, earthquake of some sort, the vibration of the building may not coincide with the vibrations of the rack system. They're different stiffness, they're made differently, they will shake differently. And so you will probably impose on either system, either the roof system or the rack, some undue forces for which it has not been designed, right? So I'm not saying it is forbidden to attach racks to the building. I'm saying that if you do, the building engineer has to be involved with the rack engineer so that they understand exactly how this new connected system will behave. Right. This other example here is the most common one. We see those quite often. Sometimes it's because of an operational issue. You know, you can see that your system is kind of wobbly. We see those when you have, like, let's say 3 beam levels on just one bay. You know, it's 2 uprights attached with beam levels, and then you don't have a long down aisle row of uprights, right? It's just 2 uprights standalone. And the connectors are quite loose. You've seen those things, they're made to be attached and detached and moved and so on, like a kit, a mechano kit. And it, depending on the type of rack system that you have, the manufacturer, the connectors might have some loose in there. And sometimes people attach their racks because they feel that during operation, they're kind of wobbly. I tell you, the solution is not to attach it to the building. Usually the solution is to really look at that kind of system and perhaps deal with it in some other way. Sometimes we have attached the connector more strongly with the upright elements, but either way, the solution must be engineered. At number 7, having inadequate aisle width. So this is a really tough one to deal with. Of course, there are limits, you know, depending on the type of forklifts that you're using. They have a their own limitations when you operate within the aisles. And of course, you can always try and teach people to be more precise or take care of the racks. But when you're in full operation, Christmas time is coming, where everybody's hurrying up. If they don't have enough clearance, they will hit the racks. It's just that simple. So the question we wanted to ask, and we're not looking who's answering what, it's just to try and find out what's the percentage of the audience that has ever changed beam levels. You have your facility, you have your racks in there, the products that come in change in volume and size. Sometimes you need to change your beams. So how many of you, and I will just launch that little poll right here, 63% of people said, yes, we do change beam levels. And so where we were heading with this was the fact that when you do change beam elevations, so number 6 is reconfiguring racks. That's okay, but if you do it without engineering, that is not okay. So in this example here, you started on the left with 4,500 pound pallets with 2 beam elevations, we can see it, at a certain height from the floor. But then you moved the beams up a little bit. The first beam elevation has climbed up and the second beam elevation as well. And now we're down, if we do the engineering, we're down to 3,000 pounds per pallet. And so the capacity of that middle upright right there is dependent on the height between the first beam elevation and the floor. Of course, there are other forces like seismic forces to consider and so on. But if we only look at gravity forces, it is controlled by that height. And that height is actually a divider of the capacity, which is elevated to the square. So it's not even a perfectly linear behavior, right? So let's say if you have 5 beam elevations, they're all equally spaced at 60 inches. Right? And you remove the first beam elevation. So you're thinking, well, I had 5 times 3,000 pounds per pallet, and now I've got 4 times 3,000 pounds per pallet. I should be good, right? But you actually diminish the capacity of that first elevation of upright until now the first beam, which was the second beam. You've diminished the capacity by a factor of 4. So the conclusion of point 6 is, yeah, you do have similar parts, but you can have different load capacities when you move the beams around. It could also happen if you had lowered the first beam elevation, you might have triggered something where you cannot put 4,500 pounds at the very top anymore, because that length between those 2 beams has increased. Moving along, at number 5, not anchoring your racking system. So anything that is operated by a forklift, a mechanical device, needs to be anchored. That is clear with the code. But of course, if you're in a seismic zone that is of rather high intensity, you have to look at what the engineers have specified. So for example, here, the engineers had specified, I need 2 anchors. Right? And you will see those things in the LARCs. These are load application and rack configuration drawings. Those are these stamp drawings by the original design engineer of the rack systems. So by the way, every one of you have to have these documents in hand or nearby because they are referred to by the building code. So building code says if you have racks, you need to respect the rack design code. And that code says that you need to maintain a set of drawings or an engineering report that states the capacity of your racks in their current state. So in this case, we were missing 1 anchor right there. There should be 2 for this one. In this case, this is a cantilever rack that we see like at the Home Depot, Lowe's, or different types of hardware store, where they are missing at least 1 anchor. It's an L-shaped cantilever rack system. So if you kind of push on it, even though there are no real pulling forces right there, everything is trying to push down, they need to be anchored. So if you come in with your lift and you hit that base, it'll just twist the column and then could create a larger issue. Another case here, we do have an anchor in place, but the nut has gone. So if there are uplift forces, down aisle forces and whatnot, this anchor is not doing much. It is just preventing horizontal movement, which is already something, but it's not doing its full job. And so we're not respecting the intent of the original design engineer. We're moving along quite fast. So at number 4, what we have is mixing and matching racking components. This is not super easy to see. So we took examples that are rather clear. In this case, you can see the big spacing that we have between the connector and the column, right? So it's normal to have some spacing. So 1/8 of an inch is often seen as normal, right? And if there is some movement at one point, you know, the connector will grab it. But not only that, for that particular connector, you can see that they're using these studs, right? And the studs are not into any holes right now. Everything is held by these little teeth that sink into the column, right? And so the code, the rack design code has changed and says you have to identify and stamp your products. So we can see that this column has been probably stamped with its name, but not necessarily the beam connector or the beam itself. So it's not super easy for someone to recognize that these don't really fit together. And not even for us, the engineers looking at these systems, you know, it's really hard to see, is this really made to fit with that type of column? Because everything, you know, the lateral stability of the whole thing is held by these connectors, right? There's nothing at the roof system attaching the top of the upright. So if it wants to move left or right, you know, in the down aisle direction, these are the connectors stopping it. So the stiffness of these beams is important, the stiffness of the connector, and they have to match with the intent of the original design. Here's another example. I'm not sure if you're familiar with the cubic style of column, but it is definitely not flat like this. It actually has the same shape as this. You know, it goes as a V shape inside and comes out as a V on the other side. And so when we see this type of connector, it becomes quite evident. It does fit the hole. Somebody could claim that it fits, but it's not enough. It has to be able to transfer the bending forces to stabilize the whole system. Now, if you have a mix and match of those, we're totally lost. We really can't tell you what's the capacity of the system. Nobody knows, because these, in order to characterize how they behave, we have to test them. And so usually what happens is the original manufacturer tests them, you know, real size test of the rigidity and behavior of these connectors with the beams and the columns. And then they can publish some sort of stiffness factor that we can do in our analysis. But if you don't have these numbers, we're kind of lost. We're getting down to the top 3. So number 3, homemade repairs. They seem obvious, and we don't show these pictures to laugh at anybody, but this is one case that we really saw in a very large warehouse that was not badly maintained. I'm not saying that, but it was, you know, a very scary case to see. So somebody, you know, probably somebody from maintenance locally, or it could happen that you buy the racks from somebody else and you haven't had somebody take a really good look at these racks, but it seems evident that you cannot do such repairs. This is super dangerous. Nobody really knows the capacity of these welds. You can see that nothing was grinded before welding, so the welds are contaminated by the paint. They're not even straight, the 3 parts together, so that doesn't really work. And when you reheat, especially cold form steel, we don't actually know the capacity or the behavior of the steel now. So again, an engineer is looking at that and cannot honestly put his name, reputation, or his company's reputation on the line. So we will say, replace this whole thing or repair it with a engineered kit. Another example, quite evident as well. Maybe it is strong enough, right? But if you ask me to prove it, I'm at a loss. I don't know what to do. I was not there when they welded it. I can see that they didn't take great care in doing it. But overall, any inspector from OSHA, anyone will look at this and say, that's not right. Get me an engineer to sign off on these things. And no engineer will sign off on it. At number 2, complacency. It could have been number 1. Honestly, it could have been. So what we're saying about complacency, don't let damages fester. This here is an example where the system, you could see that it had been hit through the years. It's still standing. So everyone's looking at it and saying, oh, it must be okay, right? Nobody has done anything about it, so it must be okay. And perhaps it is. And I'm saying this, if you want me to prove that it's okay, I'll have to take it out of there, put it under a press, destroy it, and come back and tell you, yeah, it was, right? But it was okay for this case. The next case is damaged slightly differently, and it's going to be another capacity, which I still don't know. So basically, I have to crush them all to tell you that you were okay, or that you had lost like 75% of capacity, but you were still good because you're not putting much in there. So again, any OSHA inspector, anybody with common sense looks at this and says, "Yo, come on, replace this thing, repair it, do something. Don't leave it like that." So complacency. And another word about this, in terms of engineering, what you're looking at on the left, these 2 images side by side are the buckling modes of a structural steel shape in compression, right? So on the left, you have the local buckling modes of the flanges of the C shape and the web, right? And on the right, you've got the global buckling mode, which is what you would see between 2 horizontal braces, for example, right? But when you've got the damage that we see in the middle picture, we're sort of hinting, hey, column, if you want to buckle, do it here. We're ready. We're clearing the path. You can buckle right here. And so it has not. It doesn't mean it will not as soon as we, look away. You just turn around and boom, it collapses. And these types of collapse, when we're talking about the buckling of a shape, is very violent. It's not something that's really progressive. Okay, run for your lives. No, it is down at the speed or the acceleration of gravity, let's say. And it's hard to escape. This other one shows the multiple buckling modes for cold form columns. So what you're seeing is the back of a C shape, typical 3x3 cold form steel column. And you can see that it can buckle in different mode shapes, and they sort of look like damages as well. You've seen these columns that are pinched, especially the back columns, right? When you pull out with the pallet, you squeeze a little bit, the C shape, it kind of closes, and you pull a pallet on the other side and you close that gap. Well, you're sort of hinting again that if you want to collapse, if you want to buckle Mr. Column, we're telling you where to do it with these damages. And for the number 1 thing to take care of, not using experts to inspect. It seems like I'm trying to push it to you and sell it to you, but we see it often where people train some personnel depending on the level of their training. They will go ahead and identify issues, They just don't know how to rate them. That is the number one problem, is to, well, how bad is this, right? Should we really worry? And then the people on the floor start to feel the pressure of the responsibility to flag these issues. They're kind of saying, yeah, but if I don't say it, what is my personal responsibility there? And so what we're saying is, if you're using experts for an annual inspection, for example, they come in once a year, they do it, they stand and stare at each upright, right? Each beam elevation, each safety bar, each safety pin. They look at the anchors, the front, the back. They look at the welds of the braces. So it's not your typical guy walking down the aisle. And so here's a few pictures of things they may miss. Okay, so it's rusted. How bad is it? Do I need to do something about it? Right? So it's hard for an employee, a floor employee, that, maybe he's been trained to recognize it, but how bad is it? Should I raise a flag? And now they see it every day. They kind of they don't feel it anymore. Oh yeah, I've seen it. So they don't look closer, but as time progresses, it gets worse. Another example here where we inspect and we see that situation. You see the back beam has disconnected from the right anchoring point, but there's still material on the level. So when you walk the aisle and you're just looking at the front, no problem. It doesn't look like there's an issue, but that's something. In this case, it's not going to kill anyone. There's nobody on the other side. There might be a little wall where the products could go through and hit somebody on the other side. I don't know. But these are the kinds of things that professional inspectors will find for you. Another one is that these two damages that we see. So first of all, the back column, you can see that it's gone, right? This is, you got to replace or repair this thing, the horizontal brace as well, but it was kind of hidden by that box, the carton box that we see on the left. And so that's the job of the inspector. He moves stuff around just to make sure that he saw it. Okay, oh wow, that's bad. And takes a note of it. Sometimes when it's that bad, we stop and we say, we look at the products in there and we'll say, you have to unload right now. And there we go. So back to you, Marc.
Well, thank you very much, Charles. We've covered our top 10. We have a couple more that didn't quite make it into the list. So we have what we call our honorable mentions. So let me go ahead and take control here. So first one, we have damaged pallets. Often overlooked. Certain pallets are meant for certain things. Beyond picking the wrong pallet for the application, using a pallet that's damaged. Now, this happens to be a drive-in situation where, inevitably, someone manhandled the pallet, it got, broke or it got damaged. This could lead to a traumatic event just by the sheer fact of the pallet breaking and causing this drive-in to potentially open up. So this is just an example to ensure that the pallets are in good condition. There is no rot, that there isn't other elements on there that could, deteriorate the quality of the pallets, and of course that it can't be broken or damaged as we've seen here. Unnecessary risks. So this is just like you're just asking for it, right? I mean, this is, let me double stack pallets, heavy pallets, right? This is a food and beverage facility. Heavy pallets on the top beam level of my 24-foot tall upright. So you're just asking for something to happen when you are encouraging your workers to double stack pallets because you're out of space. You're in peak. There's no more room on the floor, on the typical positions that you have. Your ends of aisles are all, floor stacked. And now you're saying, hey, look, I got to put the stuff somewhere. Go ahead. You could double stack. And the code doesn't necessarily say no to double stacking. However, it's got to be evenly distributed. You can't have pallets that are hanging like we have on the picture there, because again, you're just asking or begging for an accident to happen. So if at all possible, avoid doing that. And for those that have the eagle eye, you can see the damaged beam that's sitting under that pallet as well. So we've got a double whammy in this particular situation. Next in line, rust accumulation. So, I mean, clearly this is an outdoor application. You can see it's double posted. So the front post of the upright is still doing something, but this is again an area where, in my mind, this could have been promoted to the top 10. This is one of those instances where, this did not happen overnight. I mean, this is the letting damage fester. Well, you've got a perfect example right here of just rust taking hold of the metal and just taking a whack at it. So this is something we want to avoid at all cost. Inadequate shims. This again, outdoor application. The slab for this outdoor storage, wasn't quite level, or if it was unleveled on purpose because of rainwater having to be displaced. So folks just decided, hey, my stuff seems a bit off, so I'm going to shim my upright. This is not the way to do it. You can't be taking pavers and sticking them under your upright. If you've got a need for shims, I certainly encourage you to visit our blog and learn more about that. It all has to do with the size of the anchor. There's a limit at which you can go for shims, and this is a clear instance where you just move the beam up and let the upright sit where it's supposed to sit, anchor it, and now move the beam up a little bit into the right hole so that you're not faced with a situation like this. And again, Charles spoke to it before, folks are well-intended. I mean, they're well-intentioned in their approach to this, but unfortunately, when you're dealing with racking, pallet racking especially, there are codes that says you can't do certain things. So unlike what you might do in your backyard, if you're, putting flower pots somewhere and you want to just, elevate that post a little bit, you'll use a paver. I've done it. We just can't use that kind of reasoning and application for something like this. So now we went over a ton of things today, and I'm not trying to hit anybody over the head with this statement, but fundamentally, and we've all heard this before, if you repeat a mistake often enough, it is no longer a mistake. So if you repeat a mistake, it is not a mistake anymore, it is a decision. So the idea behind today's presentation is to highlight some things and the top that we saw as being the top 10 things that are most applicable to what you're going to see day in and day out in your various operations. So these are mistakes that we've seen take place in our time, having done this now for about 10 years and having inspected well over 100 million square feet of warehousing space. So let's recap briefly the top 10. So if you recall seeing this is inadequate protection of a building column, not using the racking as intended. Number 8, this is when we start tying the racking to the building structure. Something we want to avoid. The code does not allow that. Inadequate aisle width. So, we have to understand that once the racking is set, the aisle width is set. There isn't a whole much you can do, but don't exacerbate the situation by buying forklifts that have a turning radius that now is not compatible with that width. So again, things you want to think of before you go too long down the design of your facility. Number 6, this is when we're moving beam levels without consideration for the impact on load capacity. So to ensure that an engineer is approving that change. Number 5, not anchoring your system the way it was supposed to. The design of your racking has documentation that was stamped and will tell you how many anchors each of your base plates should have. Number 4, mixing and matching components. So not using the components that were intended for that style of racking. So if you have to replace a damaged beam, you must replace it with the same thing. Same length, same gauge of steel, same dimension, same OEM. Number 3, homemade repairs. We talked ad nauseum about this, about things to do and not to do when making a homemade repair. Number two, this is letting damage fester. And we talked about this in the previous slide about the rust kind of accumulating over time and kind of folks kind of turning their head and not kind of ignoring it. You can't let damage fester. You have to address it because it's just a matter of not if, it's a matter of when something bad could happen. Number one, this is not using experts to come in and assess the racking in your facility. So I want to leave you with a couple things. First and foremost, you're not alone. We've covered a lot of great information today. And I would tell you that for those of you that maybe don't have the in-house expertise, the staff to be able to put a program together, I encourage you to find a reliable partner. So it's someone that's going to help you plan for the long term, help you put together, the right methodologies and checklists, all those great things to help you become, a safe, have a safe environment. Have a partner versus a supplier. Everyone's a vendor. Everyone's going to try to sell you something. The partner will be different. They'll be looking out for your interests, not so much the sale, but more how can I ensure that you're well taken care of. Certainly someone that offers a wide range of products and services to address the various needs that you might have in your warehouse. Now, leveraging software, I mean, we're moving a direction of in other words, using the cloud, using information to guide us and to make sure that we're doing things right. So certainly having somebody that's able to bring that to bear is important. Having engineers on staff, having in-house engineers with that partner is incredibly important. You don't want to have to turn every minute you have a different question, having to outsource that talent or that expertise. Finding a partner that has that ability in-house, I think, is a key element. And certainly, I know for many of you, you have national or maybe in some cases international applications or operations. Having somebody that has the reach to be able to help your various needs across the geography that you serve, I think is a key thing to not overlook. Now, I would certainly wouldn't want to plug Damotech a little bit. I mean, we think it's important to at least highlight some of the things that we do really, really well. So the rack, if you go to damotech.com /resources, you're going to find a ton of great information from our rack safety blogs. I think we're just north of 70 blogs that we've written on a number of issues that I think will really educate the masses. Our rack safety guide for those that are starting from scratch, and I'm hoping there aren't too many out there, but for those of you who are kind of new to this, you've been elevated to a position where you're now responsible for rack safety, or maybe you're not responsible. You're someone in maintenance that's having to just deal with this stuff day in and day out. Our rack safety guide really kind of goes through the basics of what that means. And of course, there's a ton of downloads from checklists to how to inspect for damage and assess damage. Again, great resources for you to take a look at. Now, we have a Q&A that we can briefly go through.
So there was one about plywood. So can we use plywood instead of wire mesh decking? And the answer is always like a typical engineer will say yes, but. And so what I say is perhaps if they are specified by either the manufacturer or an engineer, and that you have in-rack sprinklers below each of these beam levels where you have plywood, because they really prevent water from trickling down. And so otherwise, we recommend wire mesh. I think it's best.
That's great. That's great. Did you have another one you mentioned?
There's another one asking about if the presentation is going to be available at the end. And yes, the recording will be made available.
Awesome. Okay. I know we're at 10 minutes before the top of the hour. Was there anything else, or have the remaining questions been answered? Okay, I think we are good. So I'll come back on screen and re-emphasize the fact that we have a quiz that you can take, kind of a self-assessment, and to motivate you to get there as quickly as you can. The first 20 participants who take this quiz will get a free rack safety poster. So we'll send that to you free of charge, and something that you could put up in your break room, in areas where your workers can see the importance of rack safety. It's a great poster. It's also on our website. So the first 20 to answer our quiz will mail you a free rack safety poster. So that takes us to the end. I'm awfully happy people joined, and I'm certainly encouraged by the attendance. And I'm hoping everyone took away some great lessons learned and things to avoid in your various warehouses. So with that, I thank you once again for your attendance, and I look forward to our next time together. Take care, everybody.